A full adder is a combinational circuit which accepts three inputs named as X, Y, Z, and it produces two outputs, namely sum. Sum is represented as capital S and carry. Carry is represented as capital C. The step number 2 of the design procedure says we have to formulate the truth table. The truth table shows the relationship between the input and the output. So here we are using a 3 variable input. So I'll be having 8 combination. So I'm writing those as X, Y, Z, sum and carry. In this X, Y, Z are the input, S and C are the output. These are all input and these are output. So 8 combinations we do have here, which will start from 0 and it ends at 7. So the first combination is all the values are 0. Next I'm going to have 0, 0, 1. The next combination is 2. How 2 is represented? 0, 1, 0. How 3 is represented? 0, 1, 1. 4 is represented as 1, 0, 0. 5 as 1, 0, 1. And 6 is represented as 1, 1, 0. Finally, 7 is represented as 111. So I have formulated the input. Now I need to say the relationship between the input and output. So what is the kind of operation the full adder is going to perform is it will do X plus Y plus Z. So whatever inputs I give, it performs the operation of X plus Y plus Z on it and it produces the sum and carry. If I add the variables X, Y, Z in which the values are all zeros, I'll get the sum as 0, then the carry as 0. And X plus Y is 0 and Y, 0 plus 1 is 1. There is no carry at all. If I'm adding 0 and 1, X is 0, Y is 1. 0 plus 1 is 1. So Y plus Z. No, my new value of Y is 1. 1 plus 0 is, my sum is 1 and the carry is 0. Now go to the fourth row in which X is 0, Y is 1. If I add 0 and 1, my answer is 1. So 1 plus 1 will give me the answer as 1, 0. In that, sum is 0, carry is 1. Now I'm going for the value 1, 0, 0. X is 1, Y is 0, Z is 0. 1 plus 0, that is X plus Y. 1 plus 0 is 1. Now my new value of Y is 1. 1 plus 0 is sum is 1. There is no carry, hence I'm putting a 0. Now 1, 0, 1. 1 plus 0 is 1. 1 plus 1 is 1, 0. In that, sum is 0, carry is 1. Now I'm coming for the combination 1, 1, 0. 1 plus 1 is 1, 0. 1, 0 plus 0 is 1, 0. So here the sum is going to be 0. My carry is going to be 1. Finally, all ones. 1 plus 1. 1 plus 1 is 1, 0. In that, if I add one more 1, my value will be 1, 1. In that, sum is named as sum and carry. So you have to formulate 2 K-map. One K-map for sum and another K-map for carry. So here we are having 8 combination. So it's better to go for a 3 variable K-map to get the reduced Boolean expression. So I'm just keeping the X on the left side, Y and Z on the other side. You have to do the labeling. Similarly on the X side too, I'm just performing the labeling part. Now I'm performing the values of cell. I'm determining the values of the cell. Once this is done, you have to look on the column with named S. Wherever ones are there, you just have to plot it because our approach is based on SOP, that is sum of product. On the cell named 1, I'm having the value as 1. On the cell named 2, I'm having the value as 1. On the cell named 4, the value is 1. And the cell named 7, the value is 1. Now you have to look like how many groups are possible here. This thing, I cannot merge any of the group, hence I have to formulate 4 groups. Each and every group consists of an individual element. So my final answer S will be, what is the value of the group associated with the cell 1? It is X bar, Y bar, Z. Now come to the group, come to the cell with the value 2. It is going to be X bar, Y, Z bar. What is the value of the cell 4? It is X bar, X, Y bar, Z bar. The value of 7 is X, Y, Z. Now you have to think of a method to simplify this. Look on the first and the fourth term. You can take Z commonly out. If you take Z commonly out, it is X bar, Y bar plus XY. Now out of the second and third term, take Z bar commonly out. It is X bar Y plus XY bar. Recall the formula of XOR and XNOR. This can also be written as Z into X XOR Y the whole bar. This is called as XNOR plus Z bar into X XOR Y. Now, if you look on this corresponding equation, it is A, this is of the form A into B bar plus A bar into B. So I can apply once again XOR here. So how I can rewrite this, this can be written as A B bar plus A bar, B can be written as A XOR B. In the place of A, I'm having Z. In the place of B, I'm having as X XOR Y. This can also be written as X XOR Y XOR Z. So this is about sum. Now you have to form another K-map for carry. So I'm just drawing another 8 cell, that is a 3 variable K-map to determine the reduced Boolean expression. So similar to our sum, I'm just going for the same kind of labeling. This is 0 0 0 1 1 1 1 0 0 1. The cells should be named. So now I'm just have a look like what are the cells you have to find. You have to fill it with the value called as 1. The cell named 3 has to be filled with 1. Next, the cell 5 has to be filled with 1. Next, 6 and 7. So 6 and 7. Okay. Now I'm just looking on what are the ways I can do the grouping. There are 3 groupings possible. The 2 elements. This is one of the group. 6 and 7 can be the other group. 3 and 7 can be the other group. So now if I write the reduced expression, C is going to be, now compare, consider the group with elements 3 and 7. It is going to be YZ. Consider the group with elements 5 and 7. Consider the group with elements 5 and 7. On the row side, you are having X, whereas you have to consider the second column and the third column. The constant is going to be Z. Come to the group with the elements 6 and 7. There also the row element is X. and the column you have to be considering 3 and 4. In that, y is constant. That's it. Now what you have to do, as per the design procedure of combinational circuit, you have to draw the logic diagram. The last step is drawing the logic diagram. So what I have to do is I have to combine both the sum and carry. So how I'm going to draw the sum, I'm just going to include an XOR gate, and to the XOR gate I'm going to take 3 inputs. The inputs are named as X, Y, Z. So this is my sum. Sum is the combination of X, XOR, Y, XOR, Z. Now I have to include the carry. The carry terms are Y and Z. That has to be multiplied. Next I need to have X and Z. That has to be multiplied. The next term I need to have is X and Y. I'll be taking X and Y. That has to be given to the AND gate. Finally, this is YZ. This is XZ. And the last term is XY. Finally, I have to feed these input to an OR gate, that is my carry. So this is how you are going to design a full